So Microsoft Research has come up with Phi-1.5, which is a small LLM, okay, which is a 1.3 billion parameter model, and this is doing good on benchmarks when compared to models of say 6 billion or 7 billion parameters. So the first Phi-1, okay, came up in this paper called Textbooks Are All You Need. So this is the second part, okay. So the idea over here is that if you train a large language model, okay, on textbook quality data, right, when compared to traditional web data, the performance improves. That is the idea. And your existing large language models were used to generate this textbook quality data. Okay, so that was Phi-1. Now they have released Phi-1.5. Okay, what they are saying is that this particular model has performance on natural language tasks comparable to models 5x larger, okay, and it surpasses most other LLMs on more complex reasoning tasks such as grade school mathematics and basic coding. Okay, it also exhibits think step by step ability, right, or it can perform rudimentary in context learning, those things also, right. This model is actually released, but this is released for research purposes, okay, right. And what they're saying is that this nearly demonstrates nearly state of art performance among models with less than 10 billion parameters. So there is no instruction following, no reinforcement learning from human feedback, okay. So this is purely traditional fine tuning, but on textbook quality data generated using your large language models, okay. That is the idea over here. So this can write poem, draft emails, create stories, summarize text, right, write Python code. It can do these things. So they also have how the code over here on how you can actually generate text using this particular model, right, that is present over here. And its architecture is a transformer based model with next word prediction objective. Dataset size was 30 billion tokens, and it just used 32 A100 40 GB graphics cards. It was trained for 8 days, right, and it was trained on this data set. Okay, now if you go to the paper over here, there is this graph which shows its performance on various benchmarks, right, how it performs across say various benchmarks. So let's go to that, right, and here is one comparison across models of similar size as well as bigger models, right, and it is comparable in performance to bigger larger model sizes, okay. So that is what they are saying over here, right. And when they evaluated in other benchmarks, okay, these are common sense reasoning benchmarks on which it was actually basically this model was trained to improve on these tasks, right. The Phi-1 was improved on these tasks for achieving this Phi-1.5. Okay, so these are common sense reasoning tasks including language understanding, mathematics, and coding. Okay, for common sense they picked up these 5 benchmarks, and here are the performances. It achieves comparable results to say a Llama 2 or a Falcon 7 billion or Vicuna 13 billion, okay, and on these common sense reasoning benchmarks. Then you have these benchmarks for language understanding and knowledge benchmarks, okay. So where again they say that it has comparable or close performance when you look at these larger models, okay, right. Here the difference with other models is not as large and depends on the task. That's what they are saying on these language understanding and knowledge benchmarks, okay. Then to evaluate reasoning abilities through mathematics and coding, they used this particular GSM 8K benchmark for elementary school math and human eval for entry level Python coding, okay. The human level or MBPP, basically this is for entry level Python coding, okay. And here they say that Phi 1.5 outperforms all existing models, including Llama 65 billion on coding tasks. That is what they are claiming over here. Okay. Right. On coding tasks, they say it is better. The Phi 1.5's coding ability is close to Phi 1.1's ability, which was purely trained for code. Okay. What they are saying is that if you use high quality textbook like data for training, the model seems to store and access the knowledge more efficiently compared to training with web data. Okay. Specifically, models trained on mixed tasks such as natural language processing and coding often show decreased accuracy, especially when the parameter count is low. But here the model is able to retain its performance when trained on a mix of tasks. So the takeaway is that if you train on high quality data, you get better results. Okay, that is what textbooks are all you need. The first paper also said. It is actually reinforced over here. Now, when I was looking at this paper and I was excited with the results, I also came up this interesting post from Susan Zhang on on Twitter or X, right? Where she says that never trust a result in 2023 that doesn't mention the risk of dataset contamination. Okay. So what she says is that I think this model is trained on the benchmark, particularly this GSM 8K. Okay. Because it has very good results on that particular benchmark. Now, why she says that is that when she took out some problems from this data set and tried running Phi 1.5 on that, it gives correct results, right? For example, if you truncate and feed a particular question, right, let's look at the question. 8th grade math question. Okay, if you take a particular question from here and give it over here, it kind of generates a particular question. It auto completes and calculates the number of downloads in the third month and does so correctly. Change the number a bit and it still answers correctly as well. Okay, so if you look at this thing over here, question is a new program had 60 downloads in the first month. The number of downloads in the second month was 3 times as many as the downloads in the first month. How do you calculate it? Okay, so it is actually doing a correct answer. That is what is being told over here. Now the thing is, if you change the format a little bit, the answer goes for a toss. Okay. And there were some questions on, say, apples. This thing, it's a mathematical question. Over here also, it gives the correct answer with reasoning. But when you change the price a little bit, it actually goes for a toss. But then to check whether the model has memorized something in this particular question, if you change a particular value, right, it continues to give the same answer because it has kind of memorized the question. So there is a possibility that some training data from this benchmark, right, from this benchmark data, some data is leaked into the training data. Okay, that's why it is doing very good results on this particular benchmark. Okay, so that's what she says. It is honestly pretty hard to believe these benchmark results on a 1 billion model if no memorization had happened. Unless we see the dataset for 5 models, there is no way to be sure that they are trained on the benchmark. So she said that she will be checking human eval and MVP next. So this is one problem which is quite common nowadays with newer papers coming out where some amount of benchmark data is actually leaking into the training data, right? And because of this, your model performs very well on benchmarks, but on real life, it may not perform as expected. Okay. So again, she says that MBPP might also be used somewhere in the Phi data set, and then she explains over here, why that could be possible, right? So not necessarily, but one has to wonder what went into these particular 6 billions of filtered code in the training data. So this is a problem. Okay, so whenever a paper releases, when you look at the benchmark results may be very good, but whether it's going to perform in the real world is not known because you don't have access to their exact training set to check whether these benchmarks are present over there, and there is always a possibility of benchmark data or evaluation data leaking into your training data. Okay, so they have given some examples over here of the prompts, right, which have been textbook like synthetic data. That is what they are showing over here. All right, for training how it improves content. That is what they have shown over here. And then let's see if there are some examples over here. Okay, let's see some other examples. So these are some kind of text generation examples, right? Using this particular model. Okay, so for example, if you give this particular prompt, and then if you give this particular prompt, the model kind of, and let's think step by step, the model kind of generates this results. So this is an apples question. Okay, suppose Alice originally had 3 apples, then Bob gave 7 apples, then Alice gave Cook 5 apples, and then Tim gave Alice 3x the amount of apples Alice had. How many apples does Alice have now? So it's like a reasoning question. Okay, where it, and let's think step by step. If you give the prompt, it generates this answer. Okay, so this is a short video about Microsoft Phi 1.5. So the idea over here is that if you have textbook data to train, very good quality data, you get good outputs. Okay, but again, if there is a leak from the benchmark data to your training data, if it is possible, then your results are very good on benchmark, but how it performs in the real world is something which only your testing will say. Okay, so that is something which you need to be aware of, like when you are looking at a research paper or a new release paper in LLMs, what was their data decontamination strategy, right? How did they make sure that the eval data is different from the training data? Okay, things like that. And currently it is only for research purposes, it is not for any commercial purposes. Okay, so I'll be putting the link to this paper and this thread from Susan Zhang on the contamination in Phi 1.5 models, as well as this Hugging Face page. You can go and check it out. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.